starfish that were fighting each other, but I think that maybe I was wrong about that, and we're actually fighting the starfish. So basically this one, I'll just read our little blurb. So today we are talking about the Crown of Thorns Starfish, or COTS. Although native to the Great Barrier Reef, it can become a significant pest when they reach outbreak densities. COT outbreaks are recognized as one of the key cumulative pressures that cause reef-wide decline and coral cover across the Great Barrier Reef. The impacts of COTS outbreaks compound the damage caused by tropical cyclones, coral bleaching events, coral disease outbreaks, and flooding events. Unlike other causes of coral mortality, strategic culling of COTS is a direct and targetable management action that can reduce coral mortality and support the resilience of the Great Barrier Reef. As part of the Great Barrier Reef's Marine Park Authority COTS control program, Blue Planet Marine has been engaged to undertake COTS control and research activities within several regions of the Great Barrier Reef Marine Park. This presentation will provide an overview of BPM's COTS control and research program in the Great Barrier Reef. So what is Reef Check? What are these crazy people on your screen hosting these events? We are all about power to the people, empowering people to be the best version of themselves in terms of looking out for the environment. So through citizen science, doing coral surveys and other things like that, cleanups and things, just helping all over the world take part in just bettering ocean health. So just some housekeeping. So we have lately been telling people to turn off their sound and video, only because it helps the bandwidth of our presentation so that we can hear Dan well. But if you want to have your video on so you feel like you're a bit more engaged, you're welcome to do that as well. But we please ask you to mute your microphone just so we don't get any feedback. You're welcome to post any questions as they come up in the chat. And depending on how Dan is feeling, we can either answer them at the end or just as we go. If you're not on our mailing list, you can email this email here and you can be added so that you never miss an event as it comes up. We do this every month on the second Tuesday. And we'll do a group photo right before we kick off. So we'll turn our screens back on if you've turned them off for that. If you want your name to be on it, you can, or if you want your face to be on it, and if you want your name to change, you can do that as well. Alrighty, so just quickly from us, we have a few upcoming events. Your Mates Brewery, if you're in Sunshine Coast, it's an amazing brewery, locally owned, really cool guys, and they're doing awesome raffle Sundays to support different causes. On March 20th, May 1st, June 12th, and July 24th, we have, will be the organization that's getting benefits from these raffles. So bring your friends and have some drinks and support us. It'd be awesome. We also have an ambassador training coming up. So if this seems like something that you're interested in or something that you might want to be involved in the future, we could always use more humans for sure. And definitely specifically on the Coastal Coral Project. So if this is something that you like doing, that's really cool. You can submit your interest by March 12th, and it starts on March 22nd, but there's a few dates. So make sure you check out our Facebook for that as well. We have just signed up to be a part of this new fundraising program. So it's an Aussie-owned zero waste company. It's called Zero Co. And they're doing a 10 million give-a-thon giveaway. So if you want to participate in that, you are more than welcome. We'd love to have you be there. And yeah, if you want to get involved to volunteer, you're more than welcome as well. We have a Facebook page that you can join if you do the ambassador training, and there's always opportunities all over to join in just as you are. Yeah, so get involved. You can find us on all of your major socials, and it'd be awesome if you are into events like this, if you share them with your friends so we can get more people coming. So thank you so much to our sponsors. Obviously, these events are all run by volunteers and people who aren't getting paid for their time. So it's really awesome to have these awesome sponsors. So we have Sunshine Coast Council, Clean Water Group, the City of Gold Coast, Mask Events, Townsville Council, and the Port of Brisbane. And a huge shout out to these humans here for helping make this show run every week or every month. So, well, sort of every week, depending on the depending on the month. So yes, very, very thankful for them. So it is now my pleasure to introduce Dan. Dr. Dan Godoy is a marine scientist who received his PhD on turtle ecology at Massey University in Auckland. Although Dan specializes in marine turtles, he's worked with a variety of species, including elasmobranchs and, I knew I was going to butcher that, patch reef communities, tropical reef fish, temperate fish, seahorses, and benthic fauna. Dan has extensive offshore experience on seismic surveys and a variety of team lead roles. Dan is currently a senior marine scientist and a project manager for the Crown of Thorns Starfish Control Project run by Blue Planet Marine. This talk will tell us all about the ongoing direct and targetable management and research of COTS in the Great Barrier Reef. So very excited to have you here, and I will pass the baton over to you, Dan. Thank you. Oh, actually, sorry, before I do that, I'm going to take a group picture. So if everybody wants to take your screen or show your screen if you're interested, I'm going to do a screenshot. Give me a second. Smile. Cool. So without further ado, I'm going to get my screen off of here and we can all welcome Dan. Thank you very much.
Hi, everyone. Can everyone hear me okay? Give a thumbs up, maybe. Yep, awesome. Thanks, Lindsay, for the introduction. And yeah, just before I guess we kick off, just really want to thank Jody and Pablo and the rest of the Reef Check team for inviting me along to be able to share with you our work on the Great Barrier Reef. Obviously, Reef Check are a great organisation that get citizen science involved and make some real changes, tangible changes out in the field. So that's great to be a part of that and to be invited to come and share with you some of our work. And particularly for Pablo for chasing me around the what do you call it, via internet for so long, trying to get me to present today is like herding cats, I'm sure. But here we are. So I guess what I'll do is, I guess this talk tonight really is a bit of a casual thing. I tend to, I'm not sure how long this will go for, but by all means, if you have a question, feel free to either send it by chat as outlined or unmute and have a chat to me. I don't mind at all. Generally, I'll go through the talk and if you have any questions that I don't know the answer to, I generally tend to make things up. So if I don't know the answer, I'll make it up. But I'll try my best to be able to answer any of your questions. And what I'll do now is I'll just share the screen. And I presume that everyone can see that now. Okay, awesome. All right, so as I guess the introduction, outlined, my name is Dan Godoy. I am the project manager for Blue Planet Marine operational side of the Crown of Thorns project on the Great Barrier Reef. My background is marine from that perspective, but also working on a number of different projects over the years in the marine management conservation sphere. I'm just going to, this vessel here is Flying Fish 5, which is our primary Crown of Thorns control vessel that's currently operating in the Southern Great Barrier Reef. And interestingly, we've just started another vessel, Infamous, out of Townsville for a short stint. So it's been quite exciting. The guys got back yesterday after their first 13-day voyage, which they achieved quite a lot. So it was really great to get that feedback today. So it's all been fairly busy, operating out right across the Great Barrier Reef Marine Park. I guess for me, the best way to initiate or start this presentation is really to try and put the context of the impact of Crown of Thorns in a larger context in relation to the Great Barrier Reef itself. And to zoom out a little bit, I guess we can describe the Great Barrier Reef. It extends over 2,000 kilometres, encompassing more than 3,000 reefs. And accordingly and justifiably, it is considered a World Heritage Site. It's It's a global icon. It has significant cultural, ecological, and economic significance. And as part of that significance and as part of the importance of the reef, not only from a regional perspective in terms of nationally, in terms of Australia, but also internationally, in all those aspects, the Great Barrier Reef Marine Park Authority is mandated with its management. And the way that it does that, and one of the aspects is it needs to monitor and manage the park's use and the various different aspects of it, whether it's cultural, ecological, or economic. And an important facet of that is to monitor its conditions over time and to identify risks and threats, improvements and declines. And the way it does that is by developing these outlook reports. Well, one of the early ones being back in 2009 and periodically again in 2014 and the latest one in 2019. From those reports, the main basis is to function as a report card to identify the threats that the reef is going on. I mean, understandably, the reef is a hugely dynamic ecosystem that can be impinged by a number of different impacts, whether right across a broad range of spatial temporal parameters. So, and that's what these outlook reports do. And what they do is they direct and identify some of those risks on which effective management can be done in field or through policy to be able to decrease those impacts and improve the quality and the resilience of the reef. I'm just going to bring up to make a little bit, oops, I've lost it. Sorry about that. I'm just going to bring up something else for me. Yeah. And in terms of the Great Barrier Reef, I guess there's four key primary pressures that the reef is in recent times has really come to the fore. That includes climate change and the associated effects of sea surface temperature, bleaching, cyclone events. And then you have historical and present impacts around commercial and industrial fishing. You have an increasing impact due to land runoff, sedimentation, eutrophication, and things like that. And then one of the fourth factors, or the fourth factor that is considered equally as important in terms of a detrimental effect on the reef, is the Crown of Thorns Starfish. And here we have an example of climate change, and we're all aware of climate change and how it's impacting not only the Great Barrier Reef, but I guess internationally, and what that means for us in the medium to long term. And this example here, we have a graph of the sea surface anomaly, or sea surface temperature anomaly, between the 1900s and up to about 2010. And this was part of the outcomes or the output from those outlook reports. And the main take-home message here is we can see the anomaly essentially is the difference in the temperature in any particular group of years, whether that be 1 year or a sequence of 5 or 10 years, the difference in temperature in relation to the long-term average or the long-term mean. And so what we can see here is in the early 1900s, right through to about fluctuating and getting less and less, or more aligned with the long-term average of 0, I guess, as you have a cooler than average temperature. But in more recent times, in the last 40 or 50 years, we're starting to get a significant increase of that temperature anomaly over the period, over the long-term mean. And what that essentially is indicating that the sea surface temperature is gradually increasing beyond the capacity by which the environment or the ecosystem and the habitats and the species can sustain over a long period and evolve at a rate that they can actually compensate for those changes. Another effect of climate change, as which we're all familiar with, is bleaching. And again, that's associated with increased sea surface temperature. And this from the 2019 Outlook report shows the number of surveyed reefs across the Great Barrier Reef Marine Park, showing those in blue, which were surveyed with little or no bleaching effect, and those with the red dots indicating those that were surveyed, yet surveyed and indicated severe bleaching. And that's over one summer, 2016 or 2017 summer period. And what that indicates is that the sea surface temperature increased to a point above that long-term average for long enough to impact the coral where bleaching events, a severe bleaching occurred. And you can see that primarily, as you could expect, that closer to the tropics, that there are longer periods of sustained increased temperatures that will result in bleaching. And interestingly, we saw a lot of this when we first started this particular project, and we saw the remnants of that still in 2018-19, those impacts. Another example is the impact of cyclones, and that is the physical damage of cyclones across the reef. And what we're seeing as a result of climate change really is not necessarily the number of cyclones that are occurring, but we're actually seeing the severity of cyclones increase. So we're getting more Category 5 cyclones occurring more often, and they create a much larger destructive swathe across the reef, which denudes and basically fragments the coral habitat and coral reefs to a point where the recovery of those reefs don't recover in time before the next or more damage occurs over time. And this is just a reflection of where those primary cyclones have been occurring naturally, and obviously those that are further north are seeing those higher frequency and severity of those cyclones. Another impact that is having a significant impact in the reef itself is water quality, and we're all aware of that, and particularly with the floods that we've recently experienced down in southeast Queensland. This is quite a poignant kind of example, and I'm sure Reef Check can get involved with that sort of thing as well, and seeing that out in the field. Essentially what this depicts here is that we see the total amount of suspended solids between 2007 and 2011. And so it's a cumulative impact, and we can see those areas that are close to the coast where there is large areas of agricultural land, high productivity, close to the coast has the largest impact of high suspended solids. And similarly, this may to a degree be impacted by industrialization of coastal areas such as port dredging, port development and things like that, but that's probably more on a local level. But ultimately we're getting this large impact and quite far ranging right out into the outer reef in some areas of sedimentation and suspended solids. And then when we come to the historical and current impact of commercial fishing, here we've got an example of 4 different types of commercial fishing. We have trawling, large mesh, bait nets, commercial line fishing, and also commercial pots between 2009 and 2012 over a 3-year period. And what this really indicates is that we have industrial fishing that's occurring across a wide area of the Great Barrier Reef Marine Park Authority and targeting all different tiers and guilds of the species in those habitats. And so it's multifaceted in terms of those theoretical impacts or actual impacts, and that are managed by fisheries. So ultimately what we have is we have these various different significant impacts to the reef. But I guess the real important message here is that you have a cumulative effect. And when you have a reef which is in an equilibrium with its environment, and it's going through this dynamic oscillation between growth and decline, and there are no, the external impacts aren't successive and efficient, or successive and detrimental to the point where that coral can't recover, you get a gradual degradation of its resilience to be able to recover. And because we've got climate change and bleaching and cyclones and overfishing and sedimentation, the cumulative effect of those impacts essentially doesn't allow the coral reefs to recover to a degree that can sustain itself. And then that's when you start getting environmental collapse and habitat collapse for these coral reefs. And there's a threshold for that, and that's and I'll talk about that a little bit later. So where does the Crown of Thorns come into that? Well, the Crown of Thorns essentially is a native species. It's a large invertebrate. It's an R-selected species, so it works on a paradigm of boom-bust population growth. And it takes advantage of some of these environmental factors which enable those, whether it's larvae or adults, to survive. And we get these boom and bust type population explosions under the right conditions. And what happens is under some of those right conditions for the Crown of Thorns, they get to a point where they're considered outbreak status. So the densities become at a level whereby the populations can't be controlled in a natural setting. The degree to which they predate on coral, on live coral, effectively starts to break down the structure of the coral reefs. And again, you end up with this denuded situation where you have a structural decline of the reef itself, which then starts to reduce the habitat quality for a myriad of other species, which essentially coral reefs underpin the whole ecosystem. And how does that happen? Well, if we take a little bit of a step back and we think about those impacts that we originally spoke about or originally outlined in terms of climate change, sedimentation, overfishing, they all actually enhance the survivability and the impact of COTS and the population explosion of COTS. So we have climate change, so you have increased temperature, which essentially increases the growth rate of larval and adult species or adult COTS. You have eutrophication or sedimentation, which increases the amount of nutrients flowing into the system. Therefore, you get an abundance of phytoplankton booms or blooms, and the larvae, therefore, of Crown of Thorns larvae can survive and grow at a much faster rate. And then you have a reduction in the natural predators of Crown of Thorns, particularly of those juveniles, such as pufferfish, trumpetfish, spangled emperors, and things like that. By reducing the numbers of those species in the ecosystem, you don't have that predation going on. So you have this multifaceted enhancement of Crown of Thorns. And that's why we end up with these population explosions. And I guess a simple way to show this is a really easy way to look at how populations of Crown of Thorns respond or impact coral reefs. And so here we got essentially the COTS work through different phases. And in a natural setting in this phase one, where you have a non-outbreak, we can consider that to be a general example of a healthy environment, a healthy coral reef, let's say, where you have a population of Crown of Thorns that are existing in equilibrium with the coral and the coral reef, its predators and so forth, and you have a stable population. In this scenario here, coral can go through its oscillation of growth and senescence and maintain a healthy level of coral cover. So here we have relative coral cover going up on the y-axis and the number of COTS on the y-axis. And over time, given some of those key facets which enhance the survivability of Crown of Thorns, as in increased temperature, increased sedimentation and eutrophication, you get these increases in survivability of larvae, settlement, recruitment into those coral reefs, and you start getting an increase in those populations into adulthood. And here we've got the similar response or the similar growth pattern of coral. It still retains, even that before that density threshold was achieved and COTS are starting to increase, you still get a relatively stable level of coral cover. However, once we pass this critical threshold, which is what we consider our catch per unit effort, which is a density threshold, which we measure to determine what that critical level is in an ecological sense, we start getting an increase. And once that the population starts to increase beyond that threshold, we start seeing an impact on the coral cover. And so as that, in that phase 3, where you get these waves of outbreaks, you have a primary outbreak that increases, and you get these waves of secondary outbreaks, and cumulative effect of Crown of Thorns, sequential Crown of Thorns populations growing and becoming outbreaks, you start getting the steady decline, and in some cases, really rapid decline of coral cover. What happens here in this, which is really critical, is that we end up with coral cover that falls below what's called a ecologically sustainable threshold, by which at this point the coral cannot recover on its own accord. So it's reduced that resilience of that coral reef to a point where it can't come back without some significant intervention. And where you have complete degradation of the Crown of Thorns or the coral cover in a reef, for example, those Crown of Thorns will either move on to other reefs, or they would decline to a point where they actually essentially eat themselves out of surviving. However, at this point here, we end up with a coral reef system which is unsustainable. So this is where we come in and we try to identify these areas so we can go on through and work those or control those Crown of Thorns populations to below density thresholds to enable those coral reefs to recover and to maintain them at a state where you don't get these outbreaks. And I think what's really important here is that this isn't it's a very dynamic system that's occurring. So in this regard, Crown of Thorns explosions or outbreaks occur in a dynamic way across the reef, so in a spatial temporal context. So here we have COTS outbreaks that's been recorded from 1983 to 2020, and you can see where some of those outbreaks initiated. And this central area here from about Cairns to just south of Townsville was the traditional historical initiation box. And this is where historically many of the Crown of Thorns outbreaks occurred. And from there, you had a gradual spread to other parts of the reef. And you had hotspots occurring where as the primary wave or the initial outbreak occurred, and then you had these secondary outbreaks migrating down the reef and impacting coral reefs and essentially denuding all these coral reefs throughout the region. But that some of that understanding is changing with the more data that we collect. So going back to this here at the bottom, you can see recovery, suppress, contain, protect, and recover. And this is the paradigm that we work under. So at any point in any point in the Great Barrier Reef, the different operators undertaking control may be at different points along this trajectory. So, for example, in the Capricorn bunkers, we're working to protect and suppress further outbreaks. We've got on top of that, but in other parts, as in the central region, we are trying to suppress and contain those outbreaks so that you don't get these secondary outbreaks moving down the reef. So how does this all fall in? How do Crown of Thorns management fall into the context of the wider aspect of the management of the Great Barrier Reef? There's these overarching documents. In 2015, there was the development of the 2050 long-term sustainability plan for the Great Barrier Reef Marine Park. And what that really did was identify objectives of what was needed to be achieved so that by 2050, we had a resilient reef established. And that was establishing a reef-wide resilience network throughout the marine park that sustains the overall resilience of the marine park. Because as we go back to the beginning where we said there's 3,000 reefs for the park, it covers in a huge area. We just don't have the resources to be able to basically manage that whole area for Crown of Thorns, let alone any other Having said that, with good science and good management techniques and strategic planning, we can identify a resilience network of reefs that if we do targeted control in a fashion by which we're efficient, we can actually manage and increase the resilience of larger areas of the reef than we actually visit. So in 2017, following the Reef Summit, the Reef Blueprint was essentially established in 2017 or produced in 2017, and that essentially established 10 initiatives within that blueprint, which could be done now to achieve those goals of the Reef 2050 long-term plan. And this encapsulates to the overarching kind of framework by which that blueprint's trying to achieve. So the idea is to build a resilience network, to build resilience within the reef so that you can help it sustain itself. And with some of those things was enhancing compliance, protect those keystone species, facilitate restoration, amongst dealing with the wider context of climate change and partnerships and awareness, in which, you know, obviously ReefCheck are very much involved in, and, you know, pushing through policy and legislation. Within here, this is where the Crown of Thorns fits in, because it is something that can be done tangibly, and it has measurable outcomes on the resilience of the reef. It can be, and so essentially, to be honest, it's very much a political win. Some people might consider it's a little bit of low-hanging fruit. It's something that can be done immediately, and the public can really get on board and support it. It's not a political hot potato, so to speak. It's not dealing with climate change. So from a political standpoint, it really makes sense. And also from an ecological standpoint, it makes sense because it's something that we can do now. It's something that we can do now that actually has tangible outcomes that we can actually measure the resilience. In contrast, things like climate change, we won't see those results for potentially decades down the track, no matter what we do. So the way that the management occurs, and I'm not going to get into this too much, but essentially there was a study that was done is to work out, okay, so we've identified the problem, we've got a good framework by which we understand the critical threats of what we can do to Crown of Thorns to reduce them below threshold, and we can get some tangible outcomes for the resilience of the reef. But how do we do it? And how do we make it in a targeted way that we can use our limited resources to be as efficient as we can? And I guess these three different A, B, C, and D basically look at different management strategies. And obviously the first one is the historical kind of paradigm that we've got where we have no management. And you get these boom busts of Crown of Thorns occurring throughout the reef. And the bust of those populations really only occurs from a natural setting that once the Crown of Thorns comes through and essentially destroys that reef. And we don't want that, obviously. And then you have tactical action where you put in a lot of resources initially, and you have that ongoing widespread action where that tactical response is taken to manage the severity of outbreaks when they occur, not necessarily being proactive, but just when they occur. And you see this gradual decline with enough resources that you'll get these pulses of Crown of Thorns explosions or outbreaks occurring at a much lower rate. Similarly, if you look at a different way of doing it, you look at a scenario where you do preventative action. So you look at some of those actions that you can do, some of those 10 initiatives, for example, awareness, compliance, managing keystone species, reducing climate change, that reduces the frequency of those outbreaks. But equally, you still get very large outbreaks that have very significant impact. So I guess that the key or the most effective response is to both combine tactical action and preventive action, where you not only do targeted control using science, but then you have the other auxiliary or supplementary kind of actions where you can deal with some of those external factors to reduce the frequency of those populations. So hopefully over time, and it seems to be working, is that we get not only the gradual decline in the size of the outbreaks, but also the frequency of those outbreaks. That is a little bit of jargon. I'm sorry if it's I waffled on a little bit, but I guess just trying to illustrate that essentially what underpins the project has really evolved over time from something that was done and admirably done by AMTO, the tourism operators way back 30 years ago, that would go out to a reef and just randomly inject as many COTS as possible or collect as many COTS as possible. Even then you were seeing large outbreaks. So it's really evolved to a point now where you have a number of different science partners and other stakeholders involved in providing information that allows the development of a very good science-based strategy to be able to effectively use those limited resources that we got to achieve those outcomes just as effectively, if not better. And ultimately, what we're trying to do is achieve this equilibrium in the ecosystem. We're not trying to eradicate COTS. We're not trying to destroy, fishing pressure or reduce or stop fishing. And we understand that, industry is going to continue. It's about returning or enhancing the resilience of the reef so that it can recover itself. And ultimately, that's what we're trying to achieve. And the way in which we do that is that we use, as I said, we use the best available science to be able to protect coral ecological assets, economic assets, and also ultimately reduce the outbreak of crown of thorns. And as I said earlier, it's not about eradication or achieving high body count. It's about managing those outbreaks. So it's a very key thing. It's not just about the Wild West out there, although it might seem it sometimes. It's we do definitely try to allocate our resources strategically. And the way in which we do that is we have some very good and very sound on water methodologies. And in the same way that the ecosystem oscillates in this dynamic kind of way, the same way that we use our methodology, we oscillate in this the cycle of undertaking man-to-toe surveillance, and that essentially is a very rapid way of which we can monitor the reef to identify. So we tow observers around the periphery of the reef, and they can determine the condition of the coral overall, and look at if there's any other impacts such as bleaching or sedimentation or cyclone damage, but importantly identify the location of crown of thorns outbreaks. And the way that we do that is by identifying scars where crown of thorns have been. So essentially, as a COT will move over a coral, it will actually extrude its stomach and envelop the coral plate, if you will, and digest the coral polyps and then reabsorb the nutrients and then move on. And what's left is a bleached skeleton. And they're really easy to indicate on a really rapid way. So this is a very efficient way to cover a lot of ground and be sensitive enough for us to identify where those key outbreaks are. Once we do that, we generally, or we can, undertake more concise and more precise reef health impact surveys. So what we do is once we've opened up a reef, we will then go to these specific areas and we will do what's called a point transect of a known area to have a bit of a closer look and record what we see there and the condition of the reef, some of those impacts, and also see if there's any impacts of crown of thorns. And then we initiate culling. And I think what I'm going to try and do is something I prepared earlier, maybe. I want to share a video, so I'm not sure where I can do that, but I will try. Where are we? So can people see that? I will actually play it. So this is the way in which we essentially cull. We move along in a reef, we identify an area where crown of thorns have been found, and we will go through and we'll use vinegar. Essentially what we do is we get acetic acid and we dilute it to a percentage. We actually dilute it to about 6%. Household vinegar is 4% acetic acid. And this is what's known as the one-shot method, although we often do more than one shot. And what he's got there, I don't know who that is actually. The diver there has what's called a gun or an applicator gun, and there's a large bayonet or a wand with a needle on the end. And what they do is there's a white bottle just up here, and that's filled with vinegar connected to the weight belt or the BCD. And if I go back, I don't know if anyone can everyone see that? Yep. Okay. So here we've got the gun. We've got a tube coming out of the white bottle into the applicator, and here we have a barrel or a piston that fills with a measured volume of 20 mils of vinegar. And as you squeeze the gun or the applicator, the vinegar goes into you inject it using a 27 gauge needle into the cot. Normally what you do is you will inject in between the arms, and what that essentially does is destabilizes the osmotic regulation of the ability of the crown of thorns, and essentially they dissolve. So all their cells pop and they die, and then they just move through. So as we go through, the crown of thorns are injected and they move through, and then we won't go back to that area for another 5 days to give it time for that vinegar to do its magic. You can also see down here the remnants of the crown of thorn where it's been feeding. And as a result of that, and through studies, we can now determine how much reef we can save by the number of cots that we inject. So we can calculate an area based on the feeding rates of crown of thorns to understand if we kill 10,000 cots, we're going to save approximately a known number of, or a known area of reef. And that's the culling. But as well as that, this program is more than just about going out and trying to inject cots and do that sort of thing, collect data from that perspective. We also are involved in supporting research. So as part of the COTS Control Innovation Program under the GBRF and other science partners such as CSIRO and AIMS, we support their research to be able to gain a better understanding of the coral reef, not only the coral reef health status, but also crown of thorns in relation to that. So we collect everything from plankton toes, water quality samples, bathymetric data, plankton toes for COTS and for predator species, and also other predators such as tritons and things like that. So that's just some of the things that we collect, and also genetic samples of crown of thorns. So I guess putting all that into context, we've got the Crown of Thorns project, which I guess was formalised more robustly in 2018 under the direct direction or the direct management of the Great Barrier Reef Marine Park Authority, where there was a substantial amount of funding over a 4-year period to undertake Crown of Thorns control and right across the Great Barrier Reef. Initially, there were 7 operators. 2 never got off the mark, and since then another 2 have fallen by the wayside, so to speak. Initially, we were allocated the far north section of the reef, and now we've moved down to the southern section of the reef. And so you can see that so at the moment, actually, we've got 7 vessels operating. So you imagine 7 vessels operating anywhere between 250 days and 300 days at sea a year. It's not a lot when you compare the actual size and the complexity of the reef. So that's why it's really important to get this targeted control and the science-based methodology in place. So specifically for BPM, I mean, like I say, we started in 2018-19 up in the far north region. That was actually really exciting, but really challenging at the same time. We surveyed 97 reefs in 9 months, covering a total area of about 1,300 kilometres. A lot of towing, a lot of big shoulders in the end of it. We saw some amazing things, but luckily, and from from a positive standpoint at least, we saw very few COTS outbreaks. And I think the large part of that was to do with the historical impacts of bleaching and cyclone events. So the coral cover wasn't to a level which we feel could have sustained an outbreak over the long term. There was a lot of recovery going on, and there's a lot of juvenile recruitment, but not necessarily that really well established coral structure. So even though there weren't a lot of coral COTS there to control, we provided really important baseline data which hadn't really been collected in that area in the past. Subsequently, we did a short stint at Keeper Reef in midsection in 2019. And just as I mentioned earlier on, we've just finished our first voyage out of Townsville yesterday, and that's why we've now done a small stint in 2022. But the majority of our work to date has really been down the southern Great Barrier Reef, and that encompasses the Capricorn Bunker Group and the Swains. An amazing area of the reef to work. We're really lucky and see some of the, to be out there and see some of the things that we do see. I get jealous of the divers and all the stuff that they get to see. But I mean, they're an amazing team and they do great work and they deserve every moment they have out there. More specifically, and I'll just focus on our southern GBR region. As I said, in 2019, we moved down to the Capricorn Bunkers and we're operating Fine Fish 5 out of the Gladstone region, out of Port of Gladstone. Now, this was actually, we've done more voyages than that now. I think we're up to about 52 voyages in the Swain, in this region. This was from November, but taking that into context, up until November, we had completed 576 days at sea, surveyed 29 reefs, and basically completed, of those surveys, 7,615 manta tows. Each manta tow is essentially your tow along for 2 minutes, and observer's tow for 2 minutes at a distance of about 204 meters. And so, and each observer at any particular time will do 15 tows at one tow set, which takes about 40 minutes. So you start getting an understanding of the amount of work involved. In terms of controlled reefs, up until that point, those 47 voyages in the Southern Great Barrier Reef, we had completed more than 6,000 hours of cull effort, 6,000 hours of a team of, from a team of 12, or total team of 12, a team of 12. From there, that includes marine crew, but a team of 8 divers. And the way that we do that is we essentially do 13-day voyages, as I said, with a team of 12 personnel, being marine crew and 8 divers. And we essentially do about 9 days of diving, doing about 4 hours of in-water work each day. In that period, we've injected more than 50,000 COTS, completed more than 900 reef health impact surveys, and one of the key things on the outcomes in the Capricorn bunkers in particular is that we've reduced those COTS numbers overall, and we've effectively reduced those COTS outbreaks to a level below ecological threshold. By now, what we're doing is we're just moving through and maintaining those outbreaks or those populations so that they don't start becoming or becoming to those outbreak status levels. And we've also commenced operations in the Swains in the last about 9 months now. And that is a completely different kettle of fish. It's a huge area. It's a complex region of reefs. It has some severe and significant outbreaks. And one boat working out there is a challenge. However, we love going out there and we love doing the best that we can out there. I guess just to focus a little bit zoom in now, using Lady Musgrave as an example of what we've done to date. For us, it's a great place to focus our area, not only from a logistical point of view, because it's kind of like our safe haven. We always go to Mussy and hang out there for a little bit. But also it's an area that when we started did have one of the largest outbreaks. And since that period in 2019, of July 2019, we've completed more than 35 visits, 140 days of actual work at that reef, encompassing 1,600 hours of culling effort, where we've injected more than 6,000 COTS. And this is a really neat example because we've actually achieved and we've been able to show the recovery of the reef there. And I guess the way that we can show that is this graph here exemplifies the catch per unit effort on the y-axis. So basically, the way that we calculate our catch per unit effort, for every minute of diving, we divide the number of COTS injected. So if we have a team of 8 divers doing 5 hours of diving, we divide the number of COTS by the time, and that gives us a catch per unit effort. So essentially what it is, it's a relative count of a density estimate. And now we have these established thresholds, which I mentioned earlier. So we know that where you have coral cover of 40% or less, our target catch per unit effort threshold should be 0.04. So 0.04 COTS per minute of diving. Where you have more than 40% coral cover, our threshold is increased to 0.08. And the reason for that is that we have more coral, which can sustain a higher level of COTS density or COTS presence, and it can still sustain itself. And what we got here is we have this fluctuating level of catch per unit effort, and these are the different size classes. So we have the very small juveniles at the bottom, which are green. You have the ones up to 150 millimeters in diameter, including the arms, and then you have 150 to 250, and then you have those that are larger than 250, I think, larger than 40, sorry, larger than 40. And you can see, I guess the take-home message here is that we, over time, so since July 2019 to the March 2021, we've seen this gradual decline in COTS density to a point now that we've got it down below threshold. So effectively, this is a measurable outcome that we can show the what we've achieved, but then in the same sense, we can still then calculate the amount of coral that we've essentially saved from predation. So I guess overall, and to kind of like to start concluding, and I'm sorry if I've gone over, I don't even know what time it is. I told you I'd ramble. Is that overall we work in a really dynamic operational environment. It's not just a matter of going out to a building site that we can control. We can't control the weather. We can't control the tides. We have logistics, and not only from an external or environmental dynamic kind of operational environment, but also a methodological one. So in other words, because we're fluxing between these different methodologies and different targets, we often find ourselves visiting up to 9 or 10 reefs in one voyage. And so it's a really big logistical task to be able to maintain that efficiency over a period of 13 days. And the reasons and the success of that largely is that we believe that the objectives and the methodology is sound, and that is shown by our outcomes. We really appreciate Grumper's knowledge base, their support, and their feedback has been absolutely invaluable. And also all the science partners involved with giving us some of those tools that we use in field to be able to make those on-water management decisions. And those, encompass those tablets, the apps, and the decision-making process, which is really beneficial for us. Effectively, what we've done in the southern region, we've been able to effectively control the outbreaks in the Capricorn bunkers and across all the board, and the Lady Muskrat is a good example of that. We've seen observed downward trend in COTS densities right throughout that region. And really, we've seen a really positive feedback from tourism operators and public stakeholders, and that's a big part for us. It's something that we take pride in. We're doing this on behalf of everybody, and it's really good to get that feedback as well. And I think for me, one of the most critical, and I guess best outcomes out of this for me has been I've really seen the development of a really highly capable and really cohesive team that work and live together offshore, and they're just amazing. They love working together, they love doing and making a difference out there, and they all get along. And sometimes, I know that it's like herding cats out there for them sometimes, and they do an amazing job, and I can't thank them enough, really. And also from a research perspective, it's great that we, be able to support that other research and different other facets to be able to understand Crown of Thorns outbreaks, including collecting live COTS, understanding the predators of COTS, for example, tritons, tissue samples, as I said earlier, bathymetric data and plankton flows. And also, an extension of that is acknowledging our funders, the Reef Trust and the Great Barrier Reef Foundation, the Marine Park Authority for everything they do for us operationally and support us, the science partners, the NEST program, Commonwealth Scientific Industrial Research organisations such as CSIRO and AIMS. And as I said earlier, our BPM team, hugely supported by behind the scenes staff. Our masters and marine crew are fantastic, and also our voyage leaders and divers. So big ups to all of them and what they've achieved over the last few years. So yeah, with that, thanks very much. I hope that it's been enlightening. And welcome to have any questions or anything like that. But I'll hand it over to someone, maybe Lindsay or Jody, to take over.
Awesome. Thank you so much for that. That was enlightening. I had no idea about any of that. I would love to ask some questions. I think there's a few coming through on the chat line, but I'll just start with mine. So I'm really interested to hear, because obviously the Marine Park Authority is a government organization. I'm just, especially now with everything else that's happening environmentally speaking, with the degradation that's happening to the reef for various different reasons. Obviously, this has been pinpointed as a very crucial issue that needs management, it needs funding, it needs, obviously they've contracted your company to, work on this. So I'm just wondering, was it just research that kind of proved that this was important enough to invest in that? Or is it more, I'm just wondering how they make those decisions, because I know that there's not just the COTS issue as well out there.
No, I think that's a really good question, and I guess that's reflected in the 2050 sustainability plan, where it identifies or tries to coalesce all those complex facets of threats and tries to identify what can be achieved in what time frames to be able to get outcomes. And so not only, yes, it was largely based on research, but it's really, I guess, historically, Crown of Thorns control historically was really driven by the tourism sector. So it was just people on the ground doing things on their own that really started it. And over the decades has evolved to a point where we start to get not only a historical context of control and input, and that was driven largely by the people on the ground, through to the incorporation and the framework, the scientific framework, where it's brought to a level now that you can do targeted control. Now, what was it that was the driver behind selecting, I think you're saying COTS control in general, or more specifically which reef? Is that what you're...
Well, yeah, it was more just in general, the project in general, like how they decided that was going to be something specific that they were going to try to work on, when I know there's other things that they're not necessarily giving as much.
Oh, I see. Yeah, the political hot potatoes, eh?
Yes.
Yeah. And look, that's a really valid point. And that's why I come back to that idea that politically it's a win-win. It's something that can be absolutely measurable. So I guess when this was formalised in 2018, and there was essentially $500 million allocated by Tony Abbott, we're on his way out. It was Tony Abbott, wasn't it? No, I'm a Kiwi, so I'm like, but so there was an allocation for a 4-year period to undertake this project. So I guess this chunk of money had been, there was a huge amount of work leading up to that. That wasn't just something that occurred overnight. There's, like I say, there's people on the ground that have been doing this for a couple of decades, and proving that if you did targeted control with better resources, you could actually make some changes. And then when you align that with the political sphere within which that particular government was working at that time, thinking, okay, what can we do that we can show that we're doing something without kind of tackling and working around the edges and some of those other issues. Here we got something tangible that we can actually focus on. So I think that it was both political, and it was actually, luckily, it was founded on good science. So I guess the way I see it is, yes, of course, I'd love all these other issues to be addressed, but I really do believe that, at least in the short to medium term, this is something that is tangible, and the decision to make it, whatever was the catalyst for that, we're actually seeing improvements and continued improvements in that, and we're seeing the results.
Right. Yeah.
I certainly don't want to get to a position where, okay, so Crown of Thorns is so great, we don't have to do anything else. I don't want that to be the end result, but certainly for at least in the short term, I think it's valid.
Yeah. Absolutely. Cool. Good answer. Doesn't sound made up. I know you said you might do that if you don't know the answer. So that sounds legit. Amazing. Alrighty. So we've had a couple of people bounce out. We have a turtle care lady, I think maybe going to a hatching, which is really exciting. Julie, another fearless leader, would like to know how the divers keep track of how many COTS and what size and they have injected on each dive.
Say that again, sorry.
Julie, I don't know if you want to clarify, but I'm just reading it as how do the divers keep track of how many COTS and what size they have injected on each dive?
Ah, good point. Okay, so let me just see. You guys don't mind if I bring up documents and stuff?
No, not at all. No? Share away.
Share away. So essentially what we do is we use a standard methodology of recording the COTS sizes of what we inject. And then we also, with our dive profiles, we can work out what our average depths are. And I'll actually show you, I'll see if I can, I'll have to bring it up. It'll take a little while. So I'll just talk in the meantime and show you something else, our method. I'm just trying to figure out where I'll show you the colored data form. And actually maybe the Reef Check team that was on there might be able to see it. Might be familiar for them too, but I'll share my screen. Where am I? Okay. So can everyone see that?
Yes.
Nice. So you can see the sheet? Yeah. So here we got a standard what's called a COTS colored data form. And we have the vessel organization, just general stuff, the reef name, the ID, the site name. So as I'm bringing it up now, and I'll show you in a second, that essentially each reef is divided into what's called a cull site. And that cull site is 500 meters long by 200 meters wide. And that was generated back in the day by an automatic algorithm, which basically looked at the reef edge and allocated a discrete size or a discrete site, and that is numbered. And then what we do is dive number, and we have our divers, our bottom time, and our average depth. Here is the cohort information that you were talking about, that Joanna was asking, and that we record the size class. So when I was showing you the video, where's my video? Right? When I was showing you the video, you'll see on here, you see this little slate here? There's a slate on the diver, and basically the pencil and record the size class. And when we get back to the boat, we'll record all that data, and we'll record the total number of COTS and the total dive time. We'll divide the two, and that's how we get our catch per unit. So once my Google Earth starts, I'll show you a cull site or a reef with all the cull sites on it.
Ooh.
Does that answer your question?
Julie, I think it was thorough. I got it. Sorry, I don't know if you can hear my sausage dog in the background. Okay, so next we have what factors do you need to consider when choosing where to focus control efforts, whether it's a new outbreak or the size or abundance or density of the COTS?
Yeah, that's a really good point. So I'll see if no, it's not really working at the moment. Oh, here we go. All right, so I'm going to show you my Google Earth. I'll share with you some of it's probably a little bit, where am I? Okay. 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 So let's use Lady Musgrave as an example, and I'll share with you the screen. Can you see that? Can you see Google Earth? Yep. Okay. So here we got Google Earth, and these are our reefs that are our target reefs. And I'll zoom in and let's say this one. This is Fairfax. It's a really nice diving there. And so you can see this the shaded these blocks, if you will, around the periphery of the reef. Each one of those is a cull site. And this was generated automatically by Compa and given to us. So you can see it's on the crest area, and each one of those is 500 meters long by 200 meters wide. And they are numbered. This is Fairfax with the ID and the number cold site. And there's 1, 2, 3, and so forth. When we do towing, and I'll see if I can find something. I'll bring up. I'm not. Yeah, this will probably be quite convoluted. But what I'll try and do is just show you an example. So when I was saying that we manti tow around each of the reefs, we use tablets that record the GPS location as we go. So each tow is 200 meters long. So here I could click onto that particular manti tow, and it shows us visually where on the reef that tow occurred. And based on the information that we record, will tell us whether in this section here scars are seen, and A means absent, gives us coral cover and other stuff, but also if there's any COTS seen. So where it's absent and scars aren't seen, it colors it green. However, if I look over here, I can see that this particular tow, which was done, I'm not sure when it was done, on voyage 61, so last September, we saw that 2 COTS were seen. So as soon as a COT is seen or a scar is present, so P is for present, it gets coloured, and then basically that actions that cold site. So wherever a tow touches one of those areas, then we open it to control. Does that kind of answer your question?
I was on mute, sorry. Very cool to see. Awesome. So next one, how do you prioritize culling efforts? Is it based on, oops, did we just, oh no, sorry. Is it based on simply the density of COTS, or is that a similar question? Sorry, I'm just rereading that. Did that answer your question as well?
I can go through our prioritization strategy.
Yeah, basically just saying prioritizing culling, yeah, versus focusing control efforts. Yeah, it is sort of similar.
I guess in addition to that is that from a
yeah,
we work on annual work plans, and those annual work plans essentially look at our target reefs, and we get, so for example in the Southern Great Barrier we've got 266 target reefs. Then what they do is they look at the different values that each of those reefs contribute. So it can be tourism value, ecological value, Crown of Thorns, COTS, or sink or source, or coral cover, or coral source, or sink. And all of those things get numbered up, and then they rank them according to value. And then based on that ranking, they'll reduce that 266 reefs to, we've currently got 57 that we can select from. And then within that, we've got 3 different rank groups. So Capricorn Bunkers is our #1 rank, and that's where we focus our primary resources, or our primary focus on control for those group of reefs. And that's how we allocate, or we prioritize which reefs we go to.
I just scrolled down the chat and they were saying jinx to each other because they had similar questions. Alrighty, this is another sort of political minded one. We have a couple, I guess, passionate people in the house. I'm with you. Are you ever concerned about the public messaging around COTS? I find most non-marine people I talk to think COTS are invasive and should be eliminated. Federal government also seems to frame COTS as the bad guys, often in a way that seems to be a distraction from their inaction on climate change.
Yeah, I think that's a really good statement, Tanya. I think the second part of, and look, I don't want to come across as negative, but certainly COTS is a low-hanging fruit. It's easy to, to highlight as they're the bad guys, and we're doing something great without, addressing some of those wider issues that the reef is facing. Absolutely. And but in terms of the public messaging, yeah, I do come across sometimes that they think that are invasive, but that's our role, right? I mean, and that's the role of, for example, organisations such as Reef Check and other organisations where they get out there and increase awareness. And through these kind of forums, we can share that information and educate the public to, these are native species. And by providing them that information, they can then go that one step further and understand what are some of those implications that why COTS are at outbreak status. So, for example, me talking about overfishing or sedimentation and things. And then hopefully through that, they can use that information to start becoming more aware about some of the wider issues and see that everything is really interconnected and start to drive some of that conversation politically.
Awesome. Yes, I think that's important. Alrighty, awesome. Does anybody else have any other questions that they didn't have down in the chat, or anything? Anybody wanting to share anything else? I have a question. It might be a really silly question. I know they don't really, it's probably a no, but do they feel the culling? Like, do they feel the injection that goes into them?
The ones that we've asked said no. No, look, I mean, yeah, it's that old chestnut about do fish feel pain.
Yeah,
I absolutely believe fish feel pain, and then just because they can't vocalize it, doesn't mean that it doesn't hurt. Certainly, being an invertebrate, they use sensory stimuli to maneuver and to move, so they've got to be able to feel their external environment. So they certainly, I guess the difference is how does that stimulus, how is that stimulus interpreted?
Interpreted. I was just going to use that word. Yeah.
So, they don't have a structured brain like larger vertebrates. I mean, they have ganglion, which is, a conglomerate of small neurons and small clusters. Does it really respond in the same way that we envision pain to be?
Yeah.
I'm not sure. But when you poke them, they do move.
Yeah. I was thinking about that because I know there's a lot of studies that show that fish will avoid pain if they can, or just marine creatures in general. So I think that that's telling, but it's also, could that be an instinctual thing? Pain is associated with dying, like that type of thing. But yeah, I wasn't sure. Ever since I saw Seaspiracy and the groupers are like watching their grouper friend get assassinated, I've just been a little bit of a soft spot for these little marine guys. That was low battery on my computer, so I might wrap this up on my side. Sorry, one more question from James. Sorry, come. The last 3 years have seen multiple flood events in the central and northern Queensland catchments, and 2020 produced another bleaching event. Do you think the next Reef Outlook report will highlight a potential for the reef to reach a tipping point for its long-term sustainability? My answer, I'm just gonna put my computer.
Yeah, I guess that's a two-pronged kind of answer in a way where, the more information that we collect, and this is what we've seen through the evolution of this program, is that the better we are at predicting environmental factors that influence the resilience of the reef. And certainly this data, certainly I would hope that it is included and it will highlight, particularly around these flooding events, will highlight how severe events can undo a lot of the work that couldn't be achieved in those previous years. So I think it's an important thing that should be highlighted. I think it's I don't think that it'll be brushed under the carpet. I think it's far too large to do that. Whether or not they got enough information to be able to accurately or precisely estimate where that tipping point is, and whether or not the trajectory based on that tipping point, that those long-term plan objectives or goals are going to be achieved is yet to be seen. But going by what the other outlook reports are, we see this continue, the same impacts are continually highlighted in each report. So the ones that you look in 2019, for example, are the same ones, very much the same ones that you looked at in 2019. So yeah, I don't have an answer whether or not that they'll be able to determine accurately whether there is a tipping point, but I think that tipping point's been already highlighted in every other report previous. This tipping point's going to happen, this tipping point's going to happen. So yeah, I'm not sure if they'll be able to determine that. Having said that, The guys that just come back from sadly, the guys that came back yesterday on Infamous, they recorded quite a substantial amount of bleaching that's occurring up there now in that central section.
Probably a question on a lot of our minds is, when is Mother Nature going to finally flip her situation on us? Awesome. Yes, a lot of good comments there, and a lot of thanks for you, Dan. Dr. Dan, I'm sorry I wasn't saying doctor before I realized when I was reading your bio. It was so rude of me, but thank you so much for your time today. I really, really appreciate you sharing this with us. I love learning about projects like this. My degree, I did an environmental management plan for the Reef as well. So it's just interesting. I always think it's interesting to hear how they prioritize everything and where the research is showing that the funding needs to go to keep this healthy and thriving for a while. So I'm really, really thankful for you sharing and being here with us today. And